guys, it's Mrs. Meek. I'm going to be showing y'all partial quotients today. Partial quotients is an alternative to long division, or as the district calls it, the standard algorithm, the way that we grew up doing division. I like this one because it involves friendly numbers and multiplication, which I think kids are more familiar with multiplying and adding versus subtracting and dividing. So I find that a lot of kids really go to this one. It's a great strategy. So I want to show you what this looks like. I'll make up a problem. It could have a remainder in it. We will be doing remainders this year in 4th grade. 486 divided by 7. Just making one off the top of my head. So what you're going to do whenever you do a partial quotient problem, and we have to make some room, is you are going to put whatever the first number is, you're going to put it in the house. You're going to draw a long line down. So you're going to do a whole bunch of math over on the right. And then the 7 is going to go on the outside. Okay? And so instead of writing like you do up here, you're not going to be doing that. You are going to be asking yourself, 7 times what can get me as close to 486 as I can without going over. Just like in division, but there's lots of possibilities. And I tell my class that there's a magic number of 50. I always start with 50, and then I ask myself, can I go higher? Can I go lower? So let's start with that. 7 times 50. Sometimes we have a hard time with that, so I always write it off to the side. Okay? 7 times 5 is 35. Add 1 0. So that means that 7 times 50 is 350. That's pretty close to 486, so I'm going to use that. I could keep going, but I want a nice friendly number, and I don't want to sit there all day and come up with one answer. So let's just use that one. So 350. Now I'm going to be subtracting. 6 minus 0 is 6. Okay. So now I have kind of a new division problem, just like in long division. Now I'm doing 7 into 136. I have to ask myself, 7 times what is going to get me as close to 136 without going over? Well, I know that 7 times 50 is 350, so it has to be something less than 50. So let's go with 20. 7 times 20, kind of halved it. I thought maybe 25 because it's halfway, but 25 is not friendly, but I can do 7 times 20 in my head, because 7 times 2 is 14, and then I add a 0 to make 140. 140 is too large, so I'm going to go with 7 times 10. Okay, 7 times 10, that's a fat fluency fact, that equals 70. That's less than 136, so I can use that. 7 times 10, again, is 70. I have to write smaller. And subtract, 6 minus 0 is 6. 13 minus 7, 7, 8, 9, 10, 11, 12, 13 equals 66. I'm still a finger user even after all these years. Okay, so I have 66 left. All right, move that out of the way. So I need to ask myself, I need to get as close to 66 as I can without going over. Well, 7 times 5 is 35, 7 times 6 is 42, 7 times 7 is 49, 7 times 8 is 56, 7 times 9 is 63. Perfect. And getting closer than that. Okay, I'm going to write my product over here, my answer to my multiplication problem. 6 minus 3 is 3, 6 minus 6 is 0. Now I've come to this point where I have to ask myself, can I multiply anything times 7 to equal 3? Okay, that's not going to work because the number is less than 7, or there's nothing I can multiply by 7 to get to 3. That means I'm done. So I'm going to stop on this side for now. I'm going to come over here to the side, and I'm going to add, because these are my little partial quotients that I have. This is the part where it can be tricky, because if you're not careful, this 9 right here could look like a 90. So you have to be careful with the placement of your numbers. So I like to come to the side and rewrite it. You do not have to, but especially in the beginning, I tell the kids to put it to the side to make sure that they're not adding it as a 9 in the tens place, because that will trip somebody up. So the answer is 69. Now we're not done because it's not just 69. There's 3 left over. So actually our answer is 69, and we just do a big R, remainder 3. That is our answer right there. We will get into remainders more in a couple weeks, so I'm not concerned about them understanding what remainders are right now. I just tell the kids that you could have something left over, and we'll talk about what that means later. But to recognize that there are leftovers. Okay, again, I'll do one where I know there will not be a remainder. So 784 divided by 2. I know there will be a remainder on this one. Okay? So we have 784. House. 2 is on the outside. Okay? So I'm multiplying. Remember, my magic number is 50. Okay? So eventually your child will probably be efficient where they don't have to go up to the side and multiply. But in the beginning, still getting used to multiplying with those zeros, they might not be able to do that very well. So I come up to the side. Okay? 2 times 5 is 10. Add 1 0 is 100. Well, I have to get all the way to 700. So I bet I could go up. Like to 100. That's a nice friendly number. 2 times 100, that equals 200. I'm going to use that one. I don't have to. I could keep going, but I don't have to. So, let's see, times 100 equals 200. That's a very friendly number. I always tell my kids, don't kill yourself trying to find this exact, 2 times 175 answer to get exactly to 784. That's just too much work. It's not worth it. Using red. Okay. Okay, subtract 4, 8, 7, 6, 5. Okay, now I'm 584. I'm going to do another 100 just because I already know it. I've already worked it out over there on the side. I know it equals 200. 4, 3. I could fit in another 200, so I'm going to multiply by 100 again. That equals another 200. Whoops. 4, 8, 1. Now I'm at 184, so 100 no longer works. So I'm going to go down 10, just because, again, friendly. 2 times 90. And when I say friendly numbers, what I mean is 10, 20, 30, 40, 50. Those are easy numbers for us to do in our head versus 7 times 25. Maybe that one's not a good example. 7 times 27. I don't know that one off the top of my head, but I can do 7 times 90 very quickly in my head. And remember, we're thinking fourth grade, as a fourth grader. 2 times 9 is 18. Okay, see, 1 0 is 180. Ooh, that's perfect. That's right below 184. So I'm going to multiply that by 90. So 2 times 90 is 180. I have 4 left. Okay. Now I know this is the multiplication fact. I know that 2 times 2 is 4. So that is 0. So I have nothing left. So this one has no remainder. I'm going to go to the side and add. 100 plus 100 plus 100 is 300. 300 plus 90 is 390. Add 2 more, you have 392. Okay? Let me show you the same problem. I wish I'd done that to the side, but that's okay. Let me show you the same problem, and let's use it with some different numbers. So we have 784 divided by 2, 4 divided by 2. Instead of using 100, like we did on this problem, let's use a bigger number. Maybe we realize that we can multiply by more. Let's see, 2 times, let's go bigger, 2 times 300. Okay, 2 times 3 is 6, add 2 0, that's 700. So times 300, and then our product, our answer is going to go down here, that equals 600. 4 minus 0 is 4, 8 minus 0 is 8, 7 minus 6 is 1. Okay, I'm at 184. I can see a 180 inside of that, so I can do 2 times 90 to get 180. So 2 times 90, 180, subtract. I have 4 left, times 2, 2 times 2 is 4, subtract, I have 0. Okay, so still have 0, and when I add it, I will still get 392. So if you'll notice, we got the same answer no matter how we broke down these numbers right here, okay? That's what I like about partial quotients versus long division, is that it's very open-ended. There's lots of different ways that we could multiply to come up to find the answer. Whereas division, there's only one right way. You have to get as close to that number without going over. There is no getting close to it. You need to get as close as you can. But this one's very open-ended. If I don't see the 100 in there, like this friend did, that's okay. I saw 300 maybe in there. I saw less. Maybe I need to go by 20, so that's what I recognize, you know, we'll subtract by 40. But the more numbers that I multiply with over here, the more likely a student is to mess up on their adding, because you know they might put the ones placed in the wrong place, or there's just so many add-ins that they might not be able to. They might mess up their adding. So I do encourage kids to try their best to multiply as big as they can, so they can avoid that problem. I will do one more problem. Let's do. We'll do the thousands, because we'll go up to the thousands by one digit in division. We do not do decimals with division in 4th grade. I believe they do in 5th grade. I correct me if I'm wrong. I'm not positive, but I think they do. Here we'll just make them a remainder. So we'll do 4,864 divided by 9. I think I already did 9, but that's okay. Okay. 4,864 divided by 9. I'm going to write really tiny for this one. Okay. I'm thinking big, giant numbers. And again, the magic number is 50. Let's start with that and see where we can go with it. So I like to off to the side. Let's start with 9 times 50. 9 times 5 is 45. Add a 0. Well, I have to go all the way to 4,000, and I've only gotten 450. I could use that and be fine. But again, I try to find the biggest number that I can. But what I recognize in this problem is if I added a 0 to 50 to make to 500, I would have 4,500, because I'd have 45 and then add 2 zeros. That one gets me really close to 4,864. So I'm going to multiply by 500. That equals 4,500. 4 minus 0 is 4, 6, 3, and then a 0. So now I'm all the way down to 364. Well, looking at my previous work, 9 times 50 is 450. So that's just a little bit above. So I need to go less than 50. So 9 times 4, let's go with 9 times 40. Okay, 9 times 4 is 36. Add a 0. Oh, that's really, really close. That's good. Okay, so let's do multiply by 40. That equals 360. Subtract, I have 4 left. Okay, this number right here is less than this number here. So that means I'm done. In other words, 9, do I have anything that 9 times whatever can equal 4? No, that's not possible. So that means I'm done. That's going to be my remainder. 500 plus 40 is 540. Yes, your child should be able to add those mentally in 4th grade. If they can't, it's okay though. Okay, it doesn't mean anything bad, but they should be able to. But 540 is not my answer. My answer is 540 remainder 4. That is my answer. So that is what partial quotients looks like. We'll spend a few days doing this, and then we will move on to the standard algorithm / long division / what, you know, lots of kids are excited to learn about, because that's what you guys have learned growing up, and me. So, and then in the end, I let them pick whichever strategy works best for them, because they're different learners than anybody else, and I want them to choose what works best for them. So, if you have any questions, let one of your teachers know. Let me know. I'm happy to help whoever, and that's it. Thank you.